This is the final section of Chapter 11, Counting Methods and Probability Theory. In this section, we're looking at expected value. The objectives: compute expected value. Use expected value to solve applied problems. Use expected value to determine the average payoff or loss in a game of chance. Expected value is defined as a mathematical way to use probabilities to determine what to expect in various situations over the long run. Expected value is used to determine premiums on insurance policies, weigh the risks versus the benefits and alternatives in business ventures, and indicate to a player of any game of chance what will happen if the game is played repeatedly. These are just a few of the ways it can be used. Standard way to compute expected value is to multiply each possible outcome by its probability and then add these products. Example 1. Find the expected value for the number of girls for a family with 3 children. A family with 3 children can have 0, 1, 2, or 3 girls. There are 8 ways that these outcomes can occur, and they are listed below. The expected value E is computed by multiplying each outcome by its probability and then adding these products. So we see that E is 0 times 1/8 plus 1 times 3/8 plus 2 times 3/8 plus 3 times 1/8. And if we go back to the preceding slide, we can see where these came from. No girls would be boy, boy, boy. That's the first one that we added in. One girl could be girl, boy, 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 girl, boy, 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 girl. 2 girls, girl, girl, boy, boy, girl, boy, girl, girl, and 3 girls would be all girls. Back to the example. That's where we got these numbers for E. We add them all together. What we have to do is we have to make them improper fractions to do so. So we have 0 plus 3 plus 6 plus 3 over 8, which adds up to be 12 over 8, or 3 over 2, reducing it, which is 1.5. So the expected value is 1.5. This means that if we record the number of girls in many different 3-child families, the average number of girls for all of these families will be 1.5, or half the children. Example 2, determining an insurance premium. An automobile insurance company has determined the probabilities for various claim amounts to the nearest $2,000 for drivers ages 16 through 21, as shown in the table at the right. Calculate the expected value and describe what it means in practical terms. So, if you look at the table, it shows the amount of the claim and the probability. So, E is equal to the sum of all these, which would be the amount of the claim is 0, probability is 0.70, so that's our first number, plus 2,000 times 0.15, plus 4,000 times 0.08, plus 6,000 times 0.05, plus 8,000 times 0.01, plus 10,000 times 0.01. So this means in the long run, when you combine all these and get the number, you get 1,100. So the average cost of a claim is $1,100, which is the very least the insurance company should charge to break even. To find the expected value of a game, multiply the gain or loss for each possible outcome by its probability, and then add the products. So in this next example, we want to find the expected value of betting $1 on the number 20 in roulette. If the ball lands on that number, which we selected 20, you're awarded $35 and you get to keep the dollar that you paid to play. If the ball lands on any of the other 37 slots, because there's 38 in a roulette wheel, you're awarded nothing and the dollar that you bet is collected. So this table shows what playing one number with a 35-1 payoff in roulette would result in. The outcome, the ball lands in 20, you would gain $35, and your probability is 1 over 38 because there's 38 slots on the roulette wheel. The other outcome is the ball doesn't land on 20, you lose $1, you don't get any money back, and it's 37 over 18. So we're going to find the expected value. The first one will be 35 times 1 over 38. The next one will be a negative 1 times 37 over 38. Watch your signs when you do this. You end up with a negative $2 over 38 or a negative 0.05. The expected value is approximately negative $0.05 or a nickel. This means that in the long run, a player can expect to lose about 5 cents for every game played. And that concludes this lesson, the last section in Chapter 11.